Algebra 2, Lesson 40 is about abstract fractional equations. You have worked with equations with fractions before, like the one you see here, and you have worked with abstract equations. That just means it's mostly or entirely variables. So now we're kind of combining both of these things. So we're starting out with this thing to remember. The easiest way to solve fractional equations like this one is to eliminate the denominators first. And the way we do that is by finding the least common multiple of the denominators and multiplying every term by that, every numerator. So this will be 15. I'd be taking 15 over 1 times each of these fractions and multiplying 15 times that side, because whatever you do to one side, you must do to the other side. If I'm multiplying the left side by 15, I multiply the right side by 15. So we have this. And then you would cross cancel, because the point of this step was to eliminate denominators. Now we multiply 3 times both of those. So 3 times 4 is 12, plus 3 times x, plus 7 times 5 equals 4 times 15. So we have that. Then we would add like terms on the left. I think I moved over too far. Okay, so 3x plus 47 equals 60. And then we would subtract 47. So 3x equals 13. And then divide both sides by the coefficient of x, so dividing by 3. And we would get 13/3 for x. Okay, so we're going to do the same sort of process, but now there aren't really any numbers, or there are very few numbers. So let's take a look at example 1. Sorry, I had to refocus. Okay, so the first step is going to be to eliminate the denominators. So we find the least common multiple, which is just ax. We take ax times every term on both sides. I put it over 1 here because they're being multiplied by fractions. Then here the x's cancel. Here the a's cancel. So in this one we have a times a squared. And here we have mx, and then cax. It can be written in whatever order, acx, it doesn't matter. Now, look back at the directions. We're solving for x. That means we need to get x by itself. The first step for that, now that we've gotten rid of denominators, is to get every term with x in it on one side of the equation. It doesn't matter which side. I could subtract cax from both sides, but then there are more steps involved because I'd have to subtract a squared also. So I'm opting for a little less work, and I'm moving mx. Subtract mx from both sides. And there they cancel. We have a squared equals cax minus mx. And then we're solving for x, so we're going to factor x out of that side of the equation. That's the common factor. Okay, so that would be ca minus m, and then we divide by the coefficient of x, which is all of that in parentheses, so ca minus m. Of course, whatever we do to one side, we do to the other side. So there we go, those cancel. X equals that, a squared over ca minus m. And that's it. We have isolated the x, we have solved for x. Of course, you hopefully remember that you cannot reduce that because a does not factor out of the denominator. It would have to do that before you could reduce. So we're done with that one. Example 2 is very similar. All right, first step, multiply everything by ma, which is the LCM of the denominators. ma, m's cancel here, A's cancel there. So now we have AX plus CMA equals YM. Okay, and look at the directions. We're solving for M this time, so everything with an M needs to be on one side of the equation and everything without it on the other side. And again, it's fewer steps if I just subtract this one, so that's what I'll do. Okay, so AX equals YM minus CMA. Factor out an M. AX equals M times Y minus CA. Divide by the coefficient of M, which again is just whatever's in the parentheses. M is by itself. It equals this. This doesn't reduce, again, because this is a binomial and only one of the terms has an A. It won't factor. So that is the end of example 2 already. And there's one more example, and then you can try some out on your own. Okay, so for this one, again, there are 4 terms this time, but it's still the same process. We look at the denominators. The LCM of those is PY, so we multiply every term on both sides by PY. Could have given us more room there. Okay, so the p's cancel here. This is 6y minus AXPY equals, the y's cancel. So then we have MP plus KPY, and we're solving for P. So every term with a P needs to be on one side, and every term without a P needs to be on the other side. That has it, and this has it. So we're going to move this over there. That was a minus, so we'll add AXPY to both sides. 6y equals, I'm going to go ahead and factor the P now. That's the next step. So P, and then from here we have an M. From here we have KY, and then AXY. And then, again, divide both sides by the coefficient of P, so M plus KY plus AXY. M plus KY plus AXY. Those cancel, P is by itself, it equals this. Okay, so in order for that y to reduce, every term here would have to have a y so that we could factor it from the denominator. They don't, it doesn't reduce, that's the end. So that's the end of our notes. Enjoy these problems.